Okay, today we're going to talk about partial fractions, which is to take a fraction basically and break it into parts. Nothing super creative about the name. And we've been doing that for a long time. You've been doing that, excuse me, since your days in algebra. You can take and break apart the numerator anyway. What we're going to do today is say, how do we break apart the denominator? That's a little bit more difficult. It won't be too bad. It does take a little bit of work, and sometimes it doesn't always work out perfectly. The stuff you guys are going to do does work out. Um, so just to give you a little bit of an example of what I'm talking about here, this part here, this is the easy stuff. That's what you've been doing, where it's a single denominator and you can break apart the numerator, right? It has one factor in that denominator and you can break it apart. This one's pretty easy to do, right? We can break that apart. I'll move this up here so we can see it. X squared divided by x is x, minus 5x divided by x is 5, and then plus the 6 divided by x. It's stuff that you guys have been doing for a long time. This is the easy one here. We can break this guy apart. But this one is a little more difficult, because how do we break this into multiple pieces? That's the difficulty that we're going to go over today, and that's what's called partial fractions, is taking it and splitting it into different parts, right? And that's what we're going to be doing. So the steps here, step number one that we kind of want to make sure of is that the numerator, the degree of the numerator anyway, is smaller than the degree of the denominator. If that is not the case, then we'll do some long division. I'll show you an example of how we use that long division again, and so that we get to that point. And then once we have that, then we will factor the denominator as much as we possibly can. That's a big key piece there. And then we do the bigger step, the break into partial fractions. So these two you already know how to do, or you've done before. It's this one that's a little bit newer. And so we'll go back to that example that we had at the front. This one, it's already done. We don't, need to do that stuff. But we don't need to do any of the long division here. We're just going to factor this stuff out. So in here, I'm just going to grab this equation. It's going to yell at me. I'll just pull this. Yeah. We don't need you to tell me what it is. I just want to edit the equation. So we take this equation and we want to break apart this denominator here, which you guys know how to do. We can take this, things multiply up to 6 and add up to -5. So that's got to be x plus 6 and x minus 1. And it doesn't matter. Obviously, you can switch the order around. That's not a big deal. But here's where the partial fractions come into place. Partial fractions, we have to be able to break this into its different the factors on the denominator. That has to happen. So there has to be something. I'm going to use the letter A. You often, if you look in the book and the way people notate it, often use with capital letters to represent our numerators. It's got to be, something, I don't know what, over x plus 6, right? Wouldn't that be nice? And then plus something more over x minus 1 over that part, right? That's kind of the key piece. And so this is sort of our kind of initial pieces to initially break it into our partial fractions. And that's what we want to be able to do here. And so once we have these two parts, we essentially have an equation that we can solve for a and b, not for x. That's not what we're solving for in this case. We're trying to figure out what are these numerators. And to do that, the idea is we would essentially multiply everything here times this basically super denominator times x plus 6, x minus 1. We'd multiply that through. And so if we do that, multiply this part times that, that would cancel that denominator. Multiply this times x plus 6 and x minus 1. That will go away, and essentially we get x minus 1 left over there. Multiply this times x plus 6 and x minus 1. Cancels part of it, and we're left with the x plus 6 part. Okay, this is the key piece in solving it. Now, some people try and jump right to doing or writing down this second line right away. I do not suggest doing that, because you lose track of the original structure and you won't know, you might not remember where quite to plug the n numbers back into, where to substitute those back in. So I suggest writing down this first one and then this second one. And now the solutions are actually pretty easy. We can see that here. So I'm just going to take this so that we can keep this in view, what we can do is we can choose x to be whatever we want, because remember, x is variable, right? We're not solving for x, it's making an entire equation. So we can kind of choose x to be whatever we want. A and b, however, are not variable, they are constants that we're trying to figure out. We're trying to figure out what exact numbers are a and b, right? Not at a given point in time. A and b are permanent solid numbers, they're constants. So in here, we can let x be whatever we want and utilize that to solve for a and b. And you can let x be anything, but there are some nice solutions that make it a whole lot easier to solve for them. And those nice solutions actually make these factors 0, right? Those are the nice things. Like you could let x be 7 if you wanted to, and you will get here, you have 7 equals a times 7 minus 1, so 6a plus 13b. That's fine. Like you'd have an equation, and you could do that again and get another linear equation, do like linear combinations, plot them in Desmos, those kind of things. But I find it easier to choose the easy things. So for example, I'm going to let x equal, in this first case, let's go -6, right? If I let x equal -6, this part is just going to die off. It's going to go away. We don't have to worry about it. So what that means then is that if we plug in -6 here, we'll have -6 is equal to -7 times a, right? That's all we have, and then we can solve that. I mean, that's pretty easy to do. That just gives us that a is equal to 6/7. Like, fairly simple to do. We can do the same thing. Like, we can do another step here. I'm going to let x be 1 to get rid of the first part, right? Let x equal 1. Then that means that 1 is equal to, right? We have 1 here equals, this stuff's dead, it's gone. And then we put 1 in here, 7b, right? And then that, we can solve that pretty easy. Divide by 7b is equal to 1/7, right? That's all that we have to do in that case. So what that means here, let's make a new slide in this one here so we can put that stuff down. So what that means is we've taken this equation, right, or this expression, essentially, and we've broken it down into its pieces. We have a is 6/7, so that would go here. B is 1/7 in that case. So I'm just going to go ahead, so I don't have to retype that whole thing. Let's just grab this guy here, and she's going to read it off to me, I suppose.
Equals the fraction.
Yeah. We don't need to listen to you. Let's just edit that equation. So like we said, a is positive 6/7. So I'll just put my 7 there. B happens to be 1/7. So I put my 1/7. And I'll put that stuff in parentheses there, right? And so that just allows us to break that whole thing down there. And now we've got this into partial fractions. And if we had to do an integral of this, which you guys will have to do in your homework, it's a lot easier to do the integral here because it's just natural log of x, 6/7 natural log of x plus 6. 1/7 natural log of x minus 1 if we did the integral there. So it makes things a lot easier to do because we can just solve those partial fractions in there. We can break a fraction apart into its pieces in that case, right? That's how we can do that. If we go down here, some things that we have to keep track of, right? So this is just what if our factors are repeated. In other words, we've got some factor that is squared, right? Some factor that is cubed. You just have to account for every single power of that. It just takes a little bit more to do, but it's not too bad. So I'm going to go back up here for a second to kind of see here. Each one of these they showed up one time, so we don't have to worry about that too much. Let's see, where are we at? This one. Okay, our repetition in factors, we have to be able to factor this thing apart. So let's grab this so we can take it here.
The fraction.
Yeah. Okay, so in here, we're going to take this denominator, break it apart. So first thing I notice, I can factor out an x, so I'm going to do that. And then we have x squared plus 2x plus 1 when we factor that x out of there. And then that allows us to basically take this denominator again, and we can factor that one more time. So now you're going to put that equal sign in there. We can factor this into x plus 1 and x plus 1. So in other words, we can factor this into x plus 1 squared, right? That is our piece there. So let's make it so that when we put in notes, it'll be nice. So now the first part is not too bad because that we're sort of used to, right? I mean, we're pretty used to this one. It's a linear term. This stuff here, though, has the squared, and that's the one that we have to account for. We have to account for every single power on that, right? So we have to do that. So what we're going to have here is that this thing is actually going to be equal to, okay, we're going to have something over x, right? And that's the first term. And then we got plus something over, let's see, x plus 1, right? And then the last thing that we do have to do, since it is squared, I have to account for that exponent as well, right? So I have to put another thing over x plus 1 squared. If this was a higher power, which I don't think that shows up in your guys' homework, but if it was like a fourth power, you'd have b over x plus 1, c over x plus 1 squared, d over x plus 1 cubed, e over x plus 1 to the fourth. You just account for every single exponent all the way up. And then from there, it's very much the same. I'm going to go through that example if you guys are going to finish this example here. But if that makes sense to you, the partial fraction, solving the rest of this, you can skip ahead a little bit. I'm just going to go through that. Again, here we would, to solve this, multiply through by this big denominator all the way across. So it's going to cancel some different pieces. So what that would look like here, it would be a times, suppose if we'd multiply everything by x times x plus 1 squared. So that would be an x plus 1 squared would be left on a. B, we would cancel one of those x plus 1s. We have bx times x plus 1. And then the last one would be cx on there. That's what we would have when we multiply by this big super denominator all the way across. And what will be left is this numerator on this other side. I'm going to keep that there. Plus 20x plus 6. Right? So let's put that in there. All right, that's our big giant piece. It looks a little ugly in here, gets a little crowded, but that's okay. And so now again, we just pick little pieces off and solve for them. It doesn't, just make things that work out really, really nice. I'm just going to grab this so I can type some more stuff. And so you can pick easy numbers. Easy things here are stuff that make things disappear one at a time, and those will or should always be factors or zeros of whatever the original denominator was, right? So if I let x equal 0, then that makes this stuff disappear because it's times 0. The b section disappears, the c section disappears, and the a section is left with 0 plus 1, so 1a. Right, so we have, as I said, in essence, 1a is equal to, or actually, let's switch that around so it stays in order. 6 is equal to 1a, right? So, and then that is pretty easy. Like a is equal to 6, right? We have that piece. Yeah, so I'll write that out just so we make sure we have that. A is equal to 6. Another one that works is let x equal -1, right? That gets rid of some pieces, correct? In fact, this one gets rid of a couple of things, right? It gets rid of the a stuff. This part goes to 0. The b stuff goes to 0. All we're left with is c. So, and then we just have to calculate up here. Here we'd have 5 minus 20 plus 6. So we'd have, I suppose in that case, 5 minus 20 plus 6 being -9 is equal to -1c, right? So then we have that c is equal to 9. And it would seem like, oh man, now what do we do to solve for b? We can't get, leave b behind while getting these two to cancel. And this is the magic of that stuff. We just take, if we get to a point where like, oh man, I can't plug something in, like 0 make this cancel. I don't want to plug in too much stuff. What we can do is just take these values that we have for a and c, use these back in the equation, and then throw everything that doesn't have a b over to the other side. And so I'm going to put those in here a little bit, and I'm going to make, let's add in a blank slide so we can kind of see that happening. So we're going to take this equation here, and we're going to put in our 6 for a and 9 for c. That's what we're going to do here. So I'm going to go into our equation here, and we said a was equal to, whoops, missed it here. A is equal to 6, C is equal to 9. So if A is equal to 6, C is equal to 9. And then what we'll do is just kind of distribute some of that stuff around. So I would take this whole equation here. Let's actually just take this part equal to, we can factor that out and distribute. Here we'd have x squared plus 2x plus 1. So we'll have a 6x squared plus 12x plus 6, right? That's what this first part would turn into here. And then we've got our extra b's, right? Plus, I'm going to distribute that through so that we can see where all the b's are at. Bx squared plus bx, and then there's this plus 9x at the very, very end here. I don't know why it's trying to line stuff up, but and then we have that. And then all we do is we take all of those pieces, anything that does not have a b value in it, subtract it over to the other side, right? We just send it over, right? That's all we need to do in this case. So here, we'd take 6x squared, we would subtract that over here. We have our negative x squared, right? Or, yeah, negative x squared on there. And then we have our 20x, right? That's going to have to get subtract 12x and subtract 9. That's 21 x's that we're subtracting away. We'll have a negative x there. And then we have a positive 6, subtract from that 6, that's gone. And so if we look at what we have left, bx squared plus bx, because we removed all those pieces, these have to match up. Notice whatever number is here for b has to be in front here. Same thing here. So our result is that b is equal to -1, right? We could just kind of put in there. So b is equal to -1. We can just kind of figure that out. And that's, a little bit strange, right? But it should line up. If you ever get to a spot where like, man, I can't get the other two to cancel out, throw the values that you have back in there, after you've used the simple values like we did here, take these numbers, throw them back in, and what should happen is everything should kind of line up and you can just match them. And it's just a matching game. Like, nope, there's the x squared stuff. It has to match with x squared. That's the basic idea on that one. Okay? So gets a little tough there, but not too bad to work through. Okay, let's see. Nonlinear factors. We'll go through two more examples on here. So things when the factors are non-linear, right? We've been doing so far that the factors are linear, even though we had multiple linear factors. Back to our last example. Multiple factors here, but the factors themselves were linear. The highest power was 1. Okay, the basic idea when we're doing these partial fractions is that the mine's blanking now. The power, or it'll come to me in a second, the power of the numerator has to be 1 higher than the power of the denominator. Degree, that's what it is. The degree of the numerator has to be 1 less than, degree of the numerator 1 less than the degree of the denominator, which happens here because they're all linear. The degree of the numerator is 1 less because it wouldn't have any variables. It would be a degree of 0. When we go to this one, this new example here, we're going to have some stuff. This section cannot break down anymore. We can't do that. So here I'm just going to grab this whole equation. So we're going to break part of it down where we can. This part, right, obviously we can break that down because we can factor out an x. It would probably still work out if you didn't factor out the x and you treated it there. It just makes it easier. The more you can factor it, the easier the math will be along the way, right? It's still going to work. You can still decompose the fraction, but it makes it a lot easier along the way. And so here we can decompose this because, again, the entire degree of the bottom is 4 and the top is 3 on there. So that's able to be decomposed. So in this case here, all we can do, I just got to grab my notes so I make sure that don't make any major mistakes, or at least any more than I normally do, right? So as we go through here, we'll just break this partial fraction up. Actually, let's insert this as a couple of different ones. So we have this guy here, and then what we do is we break this up. So the part, we'd have something over x, right? that part's kind of common like we had before, and then something over x minus 1, right? And then the last thing, we have to have something over the x squared plus 4, but we only want to be 1 degree less than that. The degree of this factor is a degree of 2. So our numerator has to be a degree of 1. So we kind of have to say something times x plus something more, right? So it's 1 degree less than what's on the bottom, right? If we had something cubed, which you guys won't, but if you did, you would put on the top cx squared plus dx plus e, right? That's what you'd have to do in order to do that. So it gets more complicated as the degree gets higher and higher and higher, as with anything in math, that kind of has to happen. So let's put that in there. Actually, we can get rid of that guy in that case. Put that whole equation in. And then very similar to what we had. So again, if the rest of the decomposition made sense for you, you can kind of skip ahead. This one, I'm just going to work the rest of this equation on out, right? So what we'd have is multiply this denominator across times everything on this side. So in here, we're going to cancel out these denominators. So this whole denominator is going to get multiplied across in here. So what that would do is that would cancel the x and leave us with x minus 1 and x squared plus 4, right, because we would cancel this guy out. We'd multiply this super denominator times b, which would leave us with x and x squared plus 4, because it would cancel the x minus 1. This one would cancel the x squared, oops, just the denominator. We cancel the x squared plus 4 and leave us with x times x minus 1. I suppose I should make sure that these guys are also in parentheses as well. And then again, our piece here, we would just go through and pick out the easy stuff to cancel off. What are the easy factors? In this case, 0 makes the denominator 0. 1 makes the denominator 0 as well. There's nothing that makes these, unless we go into complex numbers, which we're not doing in calculus. We're going to stay away from those. Just working within the real number system. So in here, let's pull this down. We can find some of those solutions. So I'm just going to take those. We will let x equal, first case, 0, which that will cancel out the b section because there's times 0, and it'll cancel out this section because this whole, the c and d section is going to go away. So if we plug in 0, here we get negative 8 is equal to 1. Here's 1 in this case, and then 4, so equal to 4a, and 1 times 4 in that case, which then gives us that a is equal to negative 2. So we have that piece, right? We'll do the other easy one, let x equal 1, right? Because that makes the denominator 0. So it kills off the a stuff, kills off the c and d stuff. All we're left with is b. So I'm going to go through this part. This front part, 2 times 1 minus 4 minus 8. So I suppose that's negative 10 when we work that out. And then that is equal to the b portion, 1, and then 1 plus 4 is 5. So that's 5b, which, oops, not 6b, 5b, which works out that b is actually equal to negative 2 also. It just happens to work out in this one. It does not always work out that way. It just happens to in here. And now we'd look back, in order to make both of these 0, we'd have to use, some complex number there, 2i or negative 2i. We don't want to work with complex numbers in this case. So again, what we do is just take these, plug them into the equation, and then solve for c and d. Just match up. Yep, that's all we're going to do is play the matching game right now. So what we're going to do, let's put in a blank slide here so we can finish off finding those pieces. In this case here, we would just plug those things in. So in here, we would take this whole equation. We're going to plug in for a, negative 2, plug in for b, negative 2, and then it's just a process of expanding, collecting what we can, moving anything without the c or d's onto the other side. Yeah. Again, if it makes sense to you, go ahead and skip ahead. I'm just going to work this stuff all the way out. I'm going to take this stuff. We're going to work these out. So this one here, we send all this stuff through. We'd have an x cubed. So I'm going to take this guy out. So if we do, work this here, we'd have x cubed, and so we'd have negative 2x cubed. Here we'd have a negative 1x squared, and then times negative 2, so plus 2x squared. Oops, lazy. Squared, we would have where was that again? Oh yeah, 4 times x times negative 2, so negative 8x squared, and then negative 4 times negative 2, positive 8. So that's just from this first section here. We have that part done. Now we'd need to expand this. So here we would have negative 2x cubed. Send it here. Oops, make that actual correct power. And then negative 2 times 4, so negative 8x. Carry the x in there. And there, that stuff's all expanded out. And then we should also expand here, which I'll do on the next piece down. So let's go down here. We'll put equals. Now we just kind of, send everything that doesn't have these C's, D's, which, this C and D section will keep. Everything else, all of these will just take over to the other side. So here, for example, we have a negative 2x cubed. We'll add that over, add over this one, so we'll have actually 6x cubes over here, because we have one here, another one from this one, another one from this one. As far as the x squareds are concerned, so I'm just going to go in order. We have a 2x squared here, no more x squared, so we'll have a negative 2x squared. Got that one in there. Our 4x squared, here's an 8x, or sorry, 4x, 8x, 8x. We have negative 16x that we're going to add over there, which would make that into a positive 12x. And so that takes care of those guys. We've done that. We have an 8, negative 8 here. So I suppose that would make into negative 16 when all is said and done on that part. Whew, a lot of work on there. I'm just taking some, keeping track of where all those variables are set. And then on this side here, we would distribute the rest of what we have, right? So I'm going to need just a couple of steps to do that. Here we'd have x squared minus x, right? So I'm going to go ahead and expand that out. Whoops, let's actually just get rid of this. So x squared minus x. And so now we can expand this part out. So we have c x cubed, right, here. Then we'd have negative c x squared. Well, let's see. Oh yeah, so we have a negative cx squared and a positive d squared. So I'm going to put those together. So actually we would have a negative c and a positive d, both having x squareds on them. All right, those would both have x squareds. We have a negative d x as well. I think, is that all of them? Okay. I think I must have made a mistake somewhere up in there. But I'll look back at that and find there. I think it's probably with this 8 or something in here. That should have canceled out. Unless I didn't grab the right number. Somewhere in there, because we can see that most of this stuff lines up. We can see that C would have to be equal to 6, which would mean that D would have to be equal to negative 12 in there. So I must have messed up somewhere in that a little bit. Maybe I'll find that mistake and go back and correct that afterwards here in just a minute. So I'll go back and find that one. So if you jump to the end of the video, I'll show that correction in there. But for right now, so we can kind of keep moving, probably made some little mistake in there. I can't quite find it in my notes right now. And I don't want to use all of your guys' time because this video is going to be long enough as it is. So I'll go back and fix that at the end. All right. Last example that I'll go over here is what if the numerator happens to be larger than the denominator, at least its degree, right? Here the degree is 3, degree of 2. What we want to do then is do long division, and I wanted to show you guys that example, if you don't, quite remember how to do long division on here, that's what we'll do in this part. So on here, to get this thing to do long division, actually I'm not going to take that whole thing, don't worry about it, go away. We just sort of set up, I can't really make the division sign on here all that well. So I just left it like this. But again, we put our stuff up top, we multiply it down below, and then we subtract those values. So here to start out with long division, we need something times x squared that equals x cubed, which is basically x, right? That's a pretty easy one to put in here. So I'm just going to actually, let's see if we can make this thing be a little nice with it. You know, we're first gonna put in, we don't need the whole thing in, just, sorry about that. But let's make this so it's color coordinated. So if you're doing this long division stuff, it can, you know, work a little bit easier for you. Let's make this thing, now let's make it red to start with. Okay, so we're gonna multiply this times this one here, right? So when we multiply this red one down here, you take x times x squared, which is going to be x cubed, right? We'd have that. X times x here would be plus x squared, and then x times negative 2 minus 2x, right? So that's when we multiply the red stuff. Now the thing we have to keep in mind is we are going to subtract this stuff from here, right? We're going to subtract it away once we write that underneath. So we're going to make that so it lines up just a little bit nicer, right? And then we would work that out. You know, some people like to put a little bar underneath saying, hey, you know, we're subtracting these things away. And so when we do subtract that, x cubed minus x cubed, that's going to be 0. This part's gone. There is no other x squared to do that, so we would be subtracting x squared. So we have negative x squared in that case. And then we have a negative x minus negative x plus 2x. I had a little bit off in my notes. So that's going to be positive x when all is said and done there. So we have negative x minus negative 2x. And then we have this last part, which is just plus 3 in that case, right? That's all we'd have. That's all we'd have there. Yep. And then after this is done, we'd go back up top and say, okay, well, what else do we need to put in there? We need something times x squared that'll be there. So that's going to be a negative 1. Let's put that maybe in blue or something like that. So we'll change this one. Let's make it, make it in this kind of blue color. And so then when we do our multiplying, again, we are going to subtract that value away. All right. That's what we would do. So we're going to subtract this stuff away. Then we'll multiply negative 1 times this. So negative x squared. Negative 1 times x is negative x. And then also negative 1 times 2 is 2 in there. And we're going to subtract those values away. Whenever we do that long division, that's what we need to do there. Give me this line. Okay, we subtract those away, and then we write down what do we have left. All said, negative x minus negative x, that thing's gone, right? X minus negative x, we'd have a 2x left in this case. Where that one comes from, 3 minus 2 is going to be plus 1 in there. Yeah, that's all we'd have left. And so how we read what we have, now that this is lower than this one, there's nothing we're going to be able to multiply it with. So how we read what's left here, what we have essentially done, right? We've taken this fraction, right? We've taken it, and we're going to break it down. That's the stuff I need to correct. We've broken it down into x minus 1. That is completely what it is, right? That worked out perfectly in the division portion, but there's a little bit left over in this part. The 2x plus 1 is still being divided there. So what we would do is we would put that as, well, we still have 2x plus 1 that is still being divided by this denominator, x plus 2. That's what we would do there, right? That stuff is still being divided. And so what we'd do is we'd leave this alone, and we'd do partial fractions on this part to split that up. And from there, it's pretty much the same as what you've been seeing, so I'm not going to go through that one as a full example there. That's kind of how you use that long division. Okay? If you want to keep walking or watching, we'll go back and fix that last one there as well. So I'll put that up here also. Found my mistake. I'm sure a bunch of you guys caught it while I was doing that, but you know, we're not in class, so nobody can yell at me while I'm doing that to point out my stupid mistakes that I'm making. So if I go back to this one here, this is that big one that we were that I was showing you guys how to work through. Then as you guys probably noticed, here in this step, we let x equal 0. Well, darn it, x equals 0. 0 minus 1 is -1. Now positive 1. So we'd have 0 minus 1 is -1. This part would be 4. So we get -4 here instead of +4. So then when we divide that out, this becomes +2. I thought I saw it in my notes. I glanced down and thought I had it right while I was talking it through, but that was wrong. So now that we update this to +2, we're gonna go back to this big guy. So let's see if we can just actually cheat and pull this whole thing in here. Let's see what it does. I'll probably try and read the whole thing off.
3 lines, line 1.
Yeah, it tries to read the whole thing. All right, so let's just edit this whole thing. So what that means in this distribution part, we're not going to have -2. That would be +2 in that case. So that's going to switch these to +2x cubed, -2x squared, +8x, and a -8 in that case. And then when we go through and send everything off to the other side, we have a 2x cubed and a -2x cubed. Those things are going to be gone. So all we're left with is a 2x cubed in that case. As far as the squareds are concerned, we have a 2x squared. We're going to send that over here to become a +2x squared in that case. As far as the x's go, there's a +8x, -8x. They're gone. So nothing affects this -4x over here. We can change that. And then we have a -8 here. We add it over, it would cancel exactly with that guy. And now we can look at these and say, oh, these line up very, very nicely. C has to be 2, right? Because that's matched there. D has to be 4 because so notice you might say, oh, it's -4, but there's actually a subtraction sign right there. And if we put that in, right, D is 4, C is 2, 4 and -2 together make +2. So everything sort of matches up. We can just match those right there. So we can just put that down and now we can actually say, so, what are we, man, I already forgot what we had. C is equal to 2. I can see that right there. And D is equal to 4. And that would allow us to put those right in there. So we'll remove all this stupid stuff that I did. That's all wrong. So let's put the correct thing in there. And now we could go back and we could, you know, replace each of these numbers and then we can integrate pretty easy from there. So if you guys have any other questions or you can't quite spot your own mistakes like me and got to take some time to go rework that, or you just need somebody else to take a look at some of your work, by all means, send me an email. You guys have been pretty good about that, but good luck on the rest of your assignment.